and I'd be happy to make the recording available if you'd like. Well, it is such a pleasure to see you. It's certainly a pleasure to see all of us talking about something which is so important. I do regret that while I'm very happy you're here and I'm happy we're all together, this is perhaps the last happy thing I tell you in the near future. There are certainly very serious things. Now, I'm going to base this talk primarily on videos that I've made because I just think that's a little more animated and a little more exciting. But if throughout this, if you're wondering, as we go through the videos on my YouTube channel, and I'll give you the address if you're interested. Why should you listen to me? The answer, well, you shouldn't. I'm just trying to, pass along information that the experts have given. So here's just kind of a warm up to something that I'm about to talk about. So this came out, I think it was 2 days ago. It's always, if you're looking for when do we have the final data on a year, it's not on December 31st. It usually takes about 2 weeks before they put all the data together and they say, here's how this year ranked in comparison to the other ones. But according to the National Oceanic and Atmospheric Association, NOAA, and according to NASA, and according to the World Meteorological Association, and the Copernicus Climate Change Service, and I could go on and on. So my point is, for this talk, I think it'll be a little more interesting with the animations that I've done. But you shouldn't listen to me, and you're not listening to me. I'm just trying to relay the experts in the field who are just relaying this all over the world 24/7, every size of every ice cap, every glacier, every temperature, and getting this through. So I'll be getting to all of this, but once again, I just try to animate the data which is out there. Okay, so climate change and global warming. First off, I do want to say, the greenhouse effect and global warming, the last thing I would ever say is that it's a bad thing. It is not a bad thing.
It's not as frigid as deep space.
The reason that I say that is because if we had no greenhouse effect, then all of the energy that reached Earth would then go back into space. And the result would be our planet would be much colder than it is right now. In fact, we wouldn't have liquid oceans. So if we didn't have gases, welcome. If we didn't have gases in the atmosphere trapping heat that would otherwise dissipate into space, Venus would have a temperature of 100 degrees Celsius, and our temperature on planet Earth would be below zero. Now, we know that it's not that. So actually, Venus has a temperature of over 400 degrees Celsius, and we are 15 degrees Celsius as a planet. So we benefit from heat trapping gases. So, first off, there are heat trapping gases in the atmosphere, and, to a certain extent, we like those. And just how they work is that energy is hitting Earth from the sun, and it comes in the way of purple wavelengths of light and ultraviolet, of blue, of green, of yellow, and reds and infrareds. But when it bounces back into space after being absorbed by things here, it is in the form of heat. Now, heat is a form of radiation called infrared radiation, and we can measure its wavelength in microns. You don't care, it's not a big part of the conversation, but I do want to say there's different kinds of heat. There's 2 microns, 7, 8, 9, and you'll see that in the next graph. So, you can measure, the wavelengths of this. It is not a surprise to us that molecules can observe different types of radiation. Look at the colors of our shirts, all right? Because if you have a green shirt, why is it green? Well, because it absorbs blue wavelengths of light. It absorbs red wavelengths of light. But when green wavelengths of light hit it, the green wavelengths bounce off. And when you look at a person with a green shirt, green light is hitting your face, and you say, that's a green shirt. And you're not seeing the other colors. And the same thing would apply to like blue shirts and red shirts, etc. Okay. You can not only absorb the colors of the visible spectrum. You can absorb ultraviolet light, which is why we put on sunblock. Our DNA absorbs UV light. That would cause mutations. But here, this is an infrared camera. So clearly the camera is picking up the climate change presentation. Oh, wonderful. Have a seat. We have 3 open chairs. Oh, thank you. And we'll get a couple more chairs if you want to put some. So clearly there's stuff coming towards the camera. So heat is a form of infrared radiation, and you can measure this here. And so then we could then ask, well, if this shirt is absorbing blue light and reflecting green light, are there things that absorb heat? All right, it is a form of radiation. And the answer is yes, and we can measure that. So for example, water absorbs heat. So when there's water in the atmosphere, like water vapor, it's helping to keep heat around our planet. Once again, we like that. Our oceans are liquid water instead of frozen because water absorbs heat. But remember I said that there are different wavelengths. There's the 2s and the 4s and the 12s, etc. Water doesn't absorb all of them. So if you notice, see, this is what we call a window. Water doesn't absorb that type of heat. So that's bouncing back into space. So then as I go through the next couple of molecules, the question is, do any of those not only absorb heat, but especially do they absorb it in the windows that water vapor doesn't? And the answer is yes. Carbon dioxide does. So carbon dioxide absorbs heat in those wavelengths. There's more. There's methane. There's nitrous oxide. And for each of those, we could measure what types of infrared radiation do they absorb, which wavelengths. And for each, this is just data. This isn't, opinion. This isn't hypothetical. You can say, all right, I'm going to shine light through this gas. I have a canister of gas. Does all of the energy go through, or does some of it get absorbed? And you can measure. Water vapor absorbs this. Methane absorbs this. So these molecules absorb heat. There is more heat around our planet, less bouncing back into space when these are in the air because they absorb it, and some of it gets reflected back to Earth. Now, I mentioned carbon dioxide. I mentioned methane, nitrous oxide. Looking to see who cares. It's a small crowd. Okay. So you're thinking, I don't care about those other ones. I mean, like carbon dioxide, isn't that the big one? Well, it is. But some of those other ones, while they aren't as abundant as carbon dioxide, they're more powerful. So just as we go through, there's something known as the global warming potential. Does carbon dioxide absorb heat? It does. However, methane absorbs 34 times as much. So if you have a kilogram of methane gas, that absorbs as much heat in the atmosphere as 34 kilograms of carbon dioxide. So we don't produce as much methane pollution as we do carbon dioxide, but it's more powerful. Nitrous oxide, which we produce like through fertilizers and a number of other human activities. It has a global warming potential of 298, so about 300, so it's 300 times. So even though it's not as abundant as the carbon dioxide, which we produce when we burn fossil fuels, nevertheless, a smaller amount goes a longer way. And then we could keep on going. So I'll mention sulfur hexafluoride, and not that anyone cares because it's such a minor component, but it has a global warming potential of over 32,000. All right, so yeah, it's stuff that we use when, in refrigerants and, electrical equipment, and a little that escapes in the air. You might say, yeah, but that's not a huge amount, but, it's 32 times more powerful as a greenhouse gas. So that is significant. Now, in this playlist, I have a lot of videos, and part of it is really redundant because if you were to look, you'd say, oh, in 2020, he said, oh, look, greenhouse gases have reached record levels. And then I made a subsequent video in 2021, greenhouse gases has reached record levels. And then in 2022. So you may start to see why there's a large number of videos in this playlist. Let's use the 2024 data, which just came out. Let's say, so as of now, how much carbon dioxide is there around planet Earth? Well, obviously, we can't go back to, when the dinosaurs were around and there was probably a horrible greenhouse gas event about 250 million years ago when 90% of life was going extinct. So we can talk about what we've been around to measure, past 150, years or so. So let's take carbon dioxide. What can we say about carbon dioxide? Well, around this time, so this is around when I'm born. I'll mention this a little bit. I was born in 1966. I'm just saying it like I'm old, but as far as like a planet goes, I'm not that old, which is why some of this is scary. All right, because when we talk about planets, we tend to deal with huge, expanses of time. There's some really significant things which have occurred in my lifetime. That's scary, all right, because as old as I am, I'm not old planet-wise. And if we're seeing big changes, as we'll see in a second. So the amount of carbon dioxide in the air in parts per million was around here, around 300. And then what has happened is it goes up and up and up because we people, we use electricity as we are right now. So coal has been burned. We use our cars, so we use petroleum, we use natural gas. We need spaces for our homes, our roads, our schools, et cetera, our farms. So we cut down trees, which are taking carbon dioxide out of the air. So all of these things will put carbon dioxide in the air. And when I was born, give or take, there were 3.5 billion people on planet Earth. There are now, it varies on who you ask, 8.1 or 8.2. So that is well over double. Once again, in my lifetime, not that old, for human population to go from like 3.5 to 8, in my life, that's a lot. So it's not surprising that the carbon dioxide has gone up and up and up. So every year, we see that there is more of this heat trapping gas in our atmosphere than there ever has been while humans have been around to measure it. That is true of carbon dioxide. Methane, which gets produced from fracking, which gets produced with rice production, a whole bunch of things. Methane levels just keep going up and up and up. And so once again, 2024 record levels, but not so surprising. We humans, there's more and more of us every year, and we're still doing the same things we've done before. So it's not surprising that methane levels keep going up. Nitrous oxide levels keep going up. Sulfur hexafluoride levels keep going up. So once again, not a surprise. Every year, the amount of molecules in the atmosphere which trap heat are higher than the year before and a record high as long as humans. So the question is, what will this do with temperature? Well, temperatures are probably going to go up. Now, before we get to temperatures, just a couple final things on carbon dioxide. There is another way. We could live sustainably with carbon dioxide. So for example, there is this carbon cycle where plants take carbon dioxide out of the air and plants turn it into bio stuff. Animals eat that, and then when the plants and animals die or do respiration or whatever they do, it goes back into the air. And if this were all we did, it just cycles over and over again, and there wouldn't be a net increase. All right, so the amount of heat trapping gas could stay the same. The problem is we realized, yes, we could burn firewood, all right, which is sustainable because the trees suck carbon out of the air, we burn it, carbon goes back into the air, and it's a cycle, and the amount of carbon dioxide in the air hasn't increased. But we said, ooh, look, there's all of these things that were alive a gazillion years ago. When they died and got buried, they took their carbon with them and it became coal or petroleum. So now we could dig up, instead of taking that tree, we could take a tree that was alive 250 million years ago and burn that. Now, that's carbon that hasn't been in the carbon cycle for a while. So that's why fossil fuels, all right, is increasing the amount of carbon dioxide in the air because it has been buried and thus out of the carbon cycle for quite some time. Right. Now, I want to leave this and get to temperature, but just two final quick things. If you wanted to go to NOAA, I mean, just fascinating data. There's so much data because you can look at, country by country, or you could look at our petroleum, our natural gas, and just fascinating to see how, our energy changes, choices affect this. You could see month by month. The most significant one, I think, is if you look at 2020, I'm sure a lot of us remember it, even if we blocked it out. We were all home. Or we're we kind of shut down large parts of society. So the significant thing is, if we were to look at the red dots month by month, January, February. So in 2019, in purple, every month was higher than 2018. In 2020, we were home. We stopped driving globally. All right. And notice the increases were not as much, but there is not a single month of 2020 where the amount of carbon dioxide in the atmosphere decreased. So let's talk about a drastic, shakeup of society. 2020 was about as drastic as we can really envision, and that did not cut down the increase. I mean, we want it to decrease, but before that, we would like it to stop increasing, and even 2020 didn't. So, that's significant. One last thing before we get into temperature is there are so many different ways that we could look at this. One is we could look at by country, all right? Because if all places on Earth start to feel negative effects from climate change, well, is anyone contributing more than that? And so, we could, as the United States, number two, up here, we could say, oh, well, look, China is, producing so many more carbon emissions than we are. And that is, certainly true. And that's a valid, standpoint that, we all need to curb it. China being a leader in this. However, another way to look at it is if you were to look at per capita, all right, how much does each person release? China has more people. And so in that sense, as we go throughout the world, that would shift. So the United States is behind places like Canada, Saudi Arabia, but it would say be ahead of China. So just pointing out, as far as global emissions, there are multiple ways to look at this. But there's just too much to talk about, so we go. If more heat trapping gas goes into the atmosphere, then we would expect to trap more heat, and then we would expect there to be overall a trend where the temperature of the planet goes up. And that is what we are observing. So in this graph, and once again, there's just so much to say. And then obviously we want to hear if you have anything you'd like to add. So before we get to the so much to say, there's slower versions of this, if you would prefer, to ponder this and go back. If we were to say, all right, if we're going to talk about temperature, do we have a baseline, something to compare to? Let's hypothetically take the 20th century, from the year 1900 to the year 2000, 100 years, and let's just say that's our baseline, our normal, all right? And so now we can compare things based on that. And that's what the yellow line represents. So if you were to say, what was the temperature of planet Earth on average in the 20th century, that's our yellow line. And now if you were to say, all right, let's compare every year to that, all right, you would start off that, oh, around 1900 at the very beginning, each line is blue going down. That means cooler than average. So if you were to look at the 1900s, the 1910s, the 1920s, every year was cooler than the 20th century average. Starting around the 1940s and through like the 1970s, some years are warmer, some years are colder. We know that weather isn't, this constant, you can always predict it, this a little warmer, a little cooler. So we see some fluctuation. But since the late 70s, there's a clear trend where every single year is warmer than average. So if we take the 20th century and say, this is what we, should come to expect, every year since the late 1970s is warmer than average. So there's this upward trend. Once again, this is the fast version. There's a slower version where I go through this. All right. Now, I would like to talk about 2024 and how hot and dry, this area was over summer, and the LA fires, et cetera. And all of those are very important. But I would argue more important is the trend, all right? Because, a couple summers ago, it was so bad that the Canadian wildfires were contaminating our air, but we didn't have to worry about that last winter. So we could say, oh, here's an event in North Carolina, this hurricane this year, or, the LA fires here. But the overall effect is just, for example, with extreme weather, it's just everywhere, not the same weather event in each place at the same time, but that's increasing. So 2024, it's important to focus on this year, but, years can go up and down. The trend, I would argue, is more important. But last year, 2023, was the hottest year on record. So the deviation from the 20th century norm was the greatest. And not only that, that was the previous hottest year. Not only was it the hottest, but by a lot. That's not only a jump, that's a big jump. All right. 2024 beat 2023. Now, this trend can go up and down a little bit. There's La Nina, El Nino. There's a bunch of things which contribute to this. It's not going to be this steady thing, but nevertheless, there is certainly a trend. This January was the hottest January on record. This February was the hottest February on record, and March and April and May and June and July up through August. And now in September, that was just the second hottest, where last year, 2023, was the hottest. So 8 months of the last year, it was the record breaker as far as temperatures here. The 13 hottest years have all occurred since 2010. So we've been measuring temperatures, for a long time, like at least 140 years. If you use a different data set, like you could go back to 170. So the fact that the hottest 13 years have all been recent, 2010, we remember, and the hottest 10 years have been the past 10 years. All right, once again, there's clearly a trend here. The hottest day on planet Earth was July 22nd of this year. All right, so we're seeing changes. Now, there's another way I like to do this, just because, I mean, there's so much data here. Like, how do we visualize this? If we could go back to 1970 and say, what was the hottest year ever? 1944, crazy hot. 1938, that was hot. 1953. So here's the list, the hottest years as of 1970. If you were to come back in 1980, wow. All right, I'm sorry. I think it has to switch in a second. Oh yeah, no, it has switched. 1944 hot, but one of the 70s years, 1977, is now in second place, etc. But things haven't changed that much. And we have a whole bunch of decades represented there, like from the 1940s to the 1930s, etc. Right. If you were now to go to 1990, wow, almost every year was from the previous decade. So the 1980s were hot. All right, compared to what we had previously seen. If you were to jump to the year 2000, notice that almost every year was in the 1990s, with only a couple from the 1980s. So the 1990s were hotter than the 80s, which was hotter than anything previous. If you then go to the year 2010, all but 1998 was a hot year, we're in the early 2000s. If you were go to 2020, all right, look at that. All right, none of the previous decade even registers. All right, and now we're 4 years into the next decade, and I'm sorry, 5, because we count 2020. So if you look, we're already, 5 of those. So there is clearly a trend. So however we represent it graphically, we can see this. It is getting hotter. Now, I'd love to say more about it, but we have other things we want to talk about. So let's do that after just a couple of quick things. This affects different people different ways, right? So I just want to say 2 things. I don't know if any of you ski at Big Bear, which is really close on the Lackawaxen. This is from last January. They opened really late. And here, this should be like their peak season. So this should be, this is one of their main black diamonds. And so, this should be as cold as it gets, as white as it gets. So people should be skiing all over the place. And they closed it. All right, so here we are in the middle of winter. Now, once again, I don't want to say like, here, look at this one little snapshot. I mean, the important thing is the trend, but some snapshots, I think, just visually carry more information. So it's getting warmer. Ski slopes should not look like that in January. I do a lot of songs. Maybe we'll even play part of one. This one, if it weren't so sad, the topic, I think. A lot of people have moved from northern parts of the U.S. to southern. People have gone to Florida or Texas, we're just seeking the heat. They don't like to shovel snow. But now a lot of them are coming back because in the past couple summers, I mean, you can be in Phoenix, Arizona, and it's over 115 degrees for like 2 weeks at a time. And a lot of people I don't like shoveling snow, but I don't like 115 degrees either. So I had a little silly song about people moving back. And so because it's like from Long Island and Minnesota and Boston, I had like, you want to sleep? You want to jump in the water? So I try to use accents with all of it. And I try to use local slang. So like, there's like a translation. So there's like the Long Island translation, the Boston. So if you're interested, maybe we can end with it. All right. So temperatures are going up. Now, we think about temperature in the air. Temperatures are going up in the water as well. So I haven't updated all of the data is just coming out for last year, 2024. So some of the things I have are like from last year. But last year were the hottest ocean temperatures ever, which is a problem, all right? Because that means that there's less oxygen that affects how stratified all the minerals, et cetera, are. But it really affects corals and diatoms because they like they like cooler temperatures and they have trouble making their corallite, shells here. So it's not just the air which is getting warmer; the oceans are getting warmer, and so this, affects things all over. And we could look at each country. China came out with something in 2023 where they were measuring the effects on their economy because there were just more and more people calling out from work. There were just days where you could not work. Like if you were to go to Phoenix, if you're a roofer in Phoenix, Arizona, you have to work at night. You can't be on a roof when it's 115 degrees. So, just there's, all sorts of events here. So, we could look at temperature from a million different directions. We think of how it's affecting us. It's affecting China, and to the point where they were actually measuring, the effect that the excess heat had on their economy, costing them $313 billion. We'll get to the cost of severe weather on the U.S. economy present. All right. So as it gets warmer, one big consequence of that is ice melts, right? So as it gets warmer, ice melts. You see that everywhere. If you go to Iceland, all right, the glaciers, they're all going, all of them. They're all shrinking. And you can see it. The glacier used to be here, and now it is here. You can see the runoff. All right, you can talk about each one, and I'm just going to let this play for a second. I've got videos of different glaciers in Iceland I was able to visit a couple years ago. And it varies because, with all of this, it's just like weather. It's not like you're going to see this perfect trend where these gradual incremental increases. Each glacier is different. Some are in mountain valleys and they're a little more insulated. Some are more exposed. So you might have some which are decreasing quickly, some which are decreasing slowly. But, there's just meltwater coming off of these glaciers everywhere you look, and every year they are getting smaller. Now, Iceland melting scares me. Greenland melting scares me much more, and Antarctica, we'll get to that. If Greenland were to melt, sea level would go up 20 feet. All right. Now, if Antarctica were to melt, it would be 200 feet. All right. So, Greenland melts and New York City's in trouble. Antarctica melts and Southern Florida is underwater. So there's different amounts of ice. So this is Greenland, but just Greenland is melting, and you can measure like when does the melt start? When does it stop each year? And you can see each year the melt is starting earlier, stopping less. You could look at the decrease in ice mass. And it's about 269 gigatons every single year, which is what Greenland has been losing. And if you say, oh, I didn't brush up on my gigatons. What is that again? A gigaton is a billion metric tons, more than 2 trillion pounds. So if you say Greenland, how much ice is not there this year because it's now water in the ocean? It's 269 trillion pounds. So just a huge amount year after year. And this is one of the multiple places we're losing it from glaciers, et cetera. So there's glaciers all over the world. If you want to visit Glacier National Park, as I do, you should go soon. All right. In the not too distant future, we may not really have glaciers at Glacier National Park. And in shorter term than that, you won't be able to get to them. You'll just be able to see them off in the distance. So Mount Rainier is the largest glacier. It's in Washington State in the continental US. And here you just see all of the meltwater coming off of that. And you can see that, the glacier, once covered this whole valley and has now receded. It is. And there's ice all over the world. Two last little clips. The Arctic. What's the Arctic doing? Well, This is why just NOAA, they measured every year. If you wanted to know today, what is the size of the Arctic ice cap? There's data. All right, someone's measuring that. If you want to compare it day, month, what was it a year ago, 5 years ago? You can do this. So once again, don't listen to me. We have incredible amounts of data where you can look at the data. You know, how big is the Antarctic land ice shelf, sea ice today? How big is the Arctic this year? And if you were to pick a month, it doesn't matter any month, what we typically see is from when it started being measured, it just goes down and down and down. All right. Now, just like we have more snow in some months than others, the Arctic, like you'd have to say, like, you know, or what month are we talking about? Like, let's just pick Marches and compare March to March, or let's just compare September to September. But if you're just doing Marches, it doesn't matter. There's a trend. All right. The ice just keeps going down and down. All right. Antarctica was really stable for the most part for the longest time. Like every now and then something happens in Antarctica which scares us. Like, you know, in 2002, a big chunk of ice, which was 1.5 times the size of Orange County, enters the ocean. So that's a lot of ice. You know, like Orange County, New York, 1.5 times that size becoming ice. But luckily, Antarctica, until very recently, has been kind of stable. All right. But now that's beginning to change. And if you were to pick a moment in time, once again, the trend is what I'd like to focus on, and not let's talk about like this March this year or March last year, but just if you were to just pick one point and say, compared to 1980 when we started measuring this ice, how much less is there? All right. You're getting like 2.6 million square kilometers. So just between like the Arctic and the Antarctic, you could pick a time and say, the area that used to be white ice, that is now blue ocean, would cover half the continental US. Now, that's important because white ice reflects light back into space. Blue ocean absorbs it. And this is what scares me. We're like, I'm sure all of us do this, and I apologize. I apologize to some of you, more specifically. As a teacher, I know a lot of, you know, my students, not all of them, not the best of the students, all right, but a lot of them just like, there's an assignment, I'll get to it. I'll get, like, when's the last time I have to do it? Like, I'll get to it then. You know, I think we all have that tendency a little bit. So, we should probably do something about climate change, but like, let's wait till it starts to get bad and then we'll do it. The problem is that might work if this was this slow incremental process, like each year just got a little worse, a little worse. And at some point we could say, all right, I guess like we have to do it. But if now it starts to increase exponentially, that changes because now you say, like, by the time it starts to get bad, you think you have time, and now maybe you don't. And the reason I say that is the ocean's not just warming incrementally. Once now you take away the ice, now you have an area half the size of the continental US, which is now absorbing sunlight rather than heating it. It's now going to start heating faster, which will melt more ice, which will then cause it to heat faster, etc. So that's why we want to do as much as we can as soon so that it doesn't start to accelerate, all right? So that we say like, oh, we really want to do something about it. It might be too late. Now, some of you may know your ice, and you may say, well, isn't that sea ice? So it's not going to raise sea level. You're right. All right. So it's land ice that when that melts, that will raise sea level. The sea ice will mean the oceans absorb more heat, except in Antarctica, because the sea ice is holding back the land ice. The land ice is not coming into the ocean because the sea ice is holding it. Now, I haven't been to Antarctica, so this is Greenland and Iceland, just kind of, and I'm asking you, imagine you're in Antarctica. So yes, that would be not all ice is the same. So if this melts, sea level doesn't go up. If the glaciers melt, sea level does. So land ice contributes. But in Antarctica, the sea ice is holding back the land ice. And in the past couple years, the Antarctica sea ice has started to destabilize, and we're starting to see it had been stable for a really long time. So that's a problem, not just because now there's more ocean that's absorbing energy, but now the land ice will be less stable. And that's the stuff that could raise sea level 200 feet. All right. So ice is melting, and I have a lot more videos on that. There's just so much going on. We don't have time. So we'll get away from ice melting. And just talk about bad weather. All right. So there has always been changes in weather. All right. And there have always been storms. I mean, we look back in history, there have been droughts and floods, and it just these are nothing new. But we can count them. We can say how many hurricanes in a year, how many floods in a year, how many wildfires in a year. And we can say, oh, they're going up. Now, once again, weather is weather, so it's not this incremental thing. But, we have lived through the most active hurricane seasons that we know. And maybe it would be of interest to say, ooh, 2020 was the highest. But once again, I think the trend is the importance. So here's April can have hurricanes. We've had this many in this year's. That's the record number for April, having one. Having 2 hurricanes in May, that's the record number. 2020, 3 in June. Look, there's 2020, 2020, 2012, etc. So when we look at those, if we were just counting hurricanes as one item, then there is an increase. Obviously, hurricanes can vary because some go out to sea and don't cause huge damage. Others hit major populated areas, and so thus the impact is going to be different. I was able to visit Puerto Rico a year after that, and so it's estimated the death toll was 5,000. Not immediately, but if you take electricity away from people for months, that affects people's ability to get to hospitals and and all of these other access to clean water, et cetera. And a year later, all right, you just go around and so many buildings still didn't have roofs and still needed repair. So if you were to fly away from Puerto Rico a year afterwards, just one of the things is you look at all the blue tarps. All right, that's a year later, that's a roof that someone doesn't have. So clearly that's impacting, their livelihood, their health, et cetera. And once again, please never, ever listen to me. All right, so I mean, all of these are, they're scientific journals which publish, all of this. So by all means, look for refereed scientific papers and research this. Well, some people don't care. Okay. And some people don't care because they live out west and they're thinking, that hurricanes aren't really something that worries me. All right. But then all of a sudden the droughts and the wildfires do. All right. And so that's the thing, rather than focus on, this one hurricane hit North Carolina or Puerto Rico, this one thing, just we're seeing increases in severe weather everywhere. All right. And so just as this is affecting the West, there is drought. You know what? Maybe why don't I start with drought? We'll get to here. Okay. So there are droughts. The West is dry, but there are some more than others. And so the U.S. government, as it measures drought, there's drought, but then there's severe drought, there is extreme drought, and then there's exceptional drought. And if you were to then just take, last year has been good out west, all right, but if 2021 was rather bad, if you were to just go month after month and ask just what parts of the West are in not only just drought, but exceptional drought, it's just a huge area. All right, obviously that contributes to wildfires, which I'll get back to in a second. Before I get to that, just kind of a comment on drought. Just once again, there's this going on over the world. Like, which images do you pick? All right, so here's one of the images I would pick. If you were to watch, there was a Matthew Perry movie with Salma Hayek way back where part of it takes place at the Hoover Dam. And if you look at certain scenes, the Hoover Dam is full at that point. All right, so you're like, oh, okay. So the Hoover Dam, like there was just water on the other side of the dam. And you say, oh, that was the early 2000s. I remember that movie kind of early, So I remember when Lake Mead, the United States' largest reservoir, looked like this. I can see it in the movie. If I go there now, what does it look like? All right. It's gone down 140 feet. That's when I took a picture. It's actually gone down more since then. When the largest reservoir goes down 140 feet, that's a sign of something. Now, that's important. There's also then the microcosm where this is where Las Vegas gets its water. If it goes down much more, water isn't going over Hoover Dam. Las Vegas has issues. The Hoover Dam is generating less electricity. So there's local impacts for the specific area, but just as kind of just to kind of depict how is this affecting the West. The water levels have certainly gone down. Now, in the past year, once again, I've got lots and lots of videos. In 2024, a little bit higher than 2023. That's good. We're still lower than 2022. So like not great. Lake Mead is still far lower than we're comfortable with. But the fact that, we're a little up from 2023, we'll take small wins when we can get that. All right. But so that's a measure of water supply there. Obviously, once water disappears, all right, well, now fire is a greater risk. And once again, I hate to focus on specifics because now this year was when Utah had a record number of wildfires, and the next year it's Colorado, and the next year it's Texas, and then this year it's California. So some years might be really bad in Oklahoma, but not as bad in California, and the next year is reversed. But once again, the trend is there is more and more drought in the Southwest, which is causing more and more wildfires, which, I mean, some people lose their lives, some people lose their homes. But then I'm sure you can relate, because even Orange County had this near Greenwood Lake this summer, there were fires. I don't know about you, but I have, it's kind of like asthma exercise. But anyway, when there's stuff in the air, like I get impacted by that, and lots of people far more. If you're living out west, there are places where just you're constantly breathing in more particulate stuff. So kids are making them more prone to asthma, aggravating asthma, just so many health effects. So, this affects not only physical lives in the immediate sense and property, but also then just overall health, et cetera. And the causes are so complex. So for example, if you look at here, you see all those dead trees. The reason those Colorado trees are dead is because it's warmer and the winters are shorter, which mean fewer bugs are killed. So there are bugs, pine beetles, which are surviving the winters in greater amounts. So therefore, they defoliate the trees die. And now it's hotter than normal, it's drier than normal, and now you've got more and more dead trees than normal. So it's all of these things accumulating for an impact on wildfire. Once again, I could go on, but there's just kind of too much to say. So this is from, once again, NOAA, the National Oceanic and Atmospheric Administration. So if you live near the coast, or like if you're in the Carolinas and you suffered a horrendous effect of a hurricane earlier this year, it's the hurricanes you're worried about. If you're living in California presently, it's the wildfires you're worried about. But if you were to just say billion-dollar natural disasters, all right, how many are there? Well, they're increasing. All right, last year was a record year. I think this year a little less, which is good. But nevertheless, every year there's just more and more. All right, so there were 27 events in the past year that cost $1 billion. Now, if you were to compare that to previous years, and before anyone says like, oh yeah, but $1 billion isn't the same now the way it was in 1980. Yeah, so you have to adjust all the dollars. So if you make it so you're comparing apples to apples, just the amount of severe storms are going up, which means, it's affecting different people. Maybe, the people out west aren't worried about the hurricanes. The people in the Carolinas aren't worried about the fires. But in general, we should all be worried, because in general, all of us are experiencing more severe weather, and all of us are now paying for it, whether it be directly, from government assistance or insurance rates. Like insurance companies say, like, I can't offer flood insurance anymore. I can't offer fire insurance anymore. It's just too expensive. So that affects the price of homes. So this is just affecting all of us. And we may get severe rain one year. If you were to go to last year here, So this is just, in addition to being part of the Bashkal Area Association, which I'm going to plug at the very end, hence because we're at the Bashkal here at Meek. I'm also on the board and a sanctuary steward for Orange County Audubon. Here's the Orange County Sanctuary near Goshen's at 6.5 Station. And you say, oh, there are the mute swans. That's great. Well, not quite as great. And then you can tell by the open mouths of the baby swans there, the cygnets. They're hot. That's how birds lose heat. They don't sweat like us. So they're hot. And also, if you know the area, you say, wait a minute, that was water last year. All right. So this year was just so hot and dry that there's no water here. All right. That was all water. That family had 6 cygnets at the beginning of the year. The year before that I saw 4 cygnets. So maybe there were 2 that died early, but I saw 4, and then 4 made it to adulthood. Here there were 6, 1 made it to adulthood and is still there. It was a hard year to get through. Somewhere in here, I have a picture of a muskrat. And you're just like, wow, like I could have touched the muskrat. And you're like, that's odd. Most muskrats don't let you get that close. Like it was exhausted. I think it was dying. Like it couldn't move. It couldn't go in the water. It couldn't cool down. So extreme weather will affect all of us differently. This is a wetland. All right. And then so, we were hot and dry this year. Maybe it'll be extreme, weather next year. But this is certainly impacting us. Now, we also care about wildlife. So just kind of a quick thoughts on that, and then I'll start to sum up. Once again, there's just so many things to say. There is global warming. All right, so there's a trend where the planet is getting warmer. All right, so that's one thing. But then this is inducing climate change, and climate change means change. So what does that mean? It means a lot of things. Let me just give a couple of examples, but given such a big planet, these are just examples of things that you might see. If you were, before it got so hot and dry, so this would have been early in the spring, in Goshen, you would have seen this. And you say, that's awesome. That's a little blue heron. They're not from around here. I mean, if you were in Virginia or the Carolinas, you would see little blue herons, but like Florida, you see them everywhere. That's not a bird from around. That's kind of cool that you would see those. Well, there's a change. We're seeing animals shift their ranges. All right, we could go through a whole list of things in our area. We're seeing more and more of, that's an immature little blue heron. But Carolina wrens, we're seeing more and more of. Red-bellied woodpeckers, black vultures didn't used to occur this far north. So as the climate changes, there's changes. All right, so we'll see more wildlife. As far as the wildlife goes, well, diseases are changing. Predators and invasive species are changing. So as we look at these ecosystems, there's new plants which are spreading, which hadn't really been there. Well, we're changing the amount of rainfall areas get. We're affecting the temperature. Of course, plants and insects are going to be affected. 2 other. Okay. And of the 2 other ones, I see one of them. So anyway. Just 2 more dramatic things, just because, yes, we think about Orange County, but, we care about the world as well. If you were to go to the Galapagos, which I had the great pleasure to do this summer, you really get the idea of the currents because you have to swim in them. And you're like, okay, I have to work today. Like I'm swimming against the current. You get it, and you can actually see it. Like if you look here, with these sea turtles, you can actually see the currents. Well, the currents change on the El Nino and La Nina years. And in La Nina years, it's the currents bring all this food. So there's fish everywhere, then there's turtles and there's seabirds everywhere. But then it gets drier on land, so all the leaves fall. So if you're in the Galapagos, if you're living on land, La Nina is harder than El Nino. But if you're in the water, El Nino is harder. So like if you go in an El Nino year, like, oh, I'm going to see marine iguanas, you see all their skeletons. All right, we're like 80% of their population size. So that's just a natural cycle, El Nino and La Nina. However, with climate change, El Nino is coming more frequently and the events are more severe. So it's not just everything's getting a little bit warmer. Like in the Galapagos, oh, All right, so that's going to affect life on land and life in the ocean in ways that you're not going to see elsewhere. Now, I was able to, I'm sorry, I've lost a video that was made like 2 days ago because I was in Costa Rica like 3 days ago. Let's go to Costa Rica. So and just while I'm doing this, if anyone cares, I have a YouTube channel at Dr. Jan 41, DRJAHN 41. And, all of these videos on climate change and local wildlife, like local birds and all of these other sorts of things are here. So if you were to go to Costa Rica right now and go to the western part, Guanacaste.
If you ever get the chance to visit Costa
All right, you'd see this and you say, beautiful. That's exactly what I'd expect in Costa Rica. You're like, look at how lush, all the green, and then you'd see like animals in there, you'd see monkeys, etc. But then if you talk to Costa Ricans, they're like, yeah, this is weird. All right, because this part, it's not a tropical rainforest. They have dry seasons, so dry where it just stops raining for like 3 months, and all the leaves drop. So here, the leaves fall because of cold. In Costa Rica, they drop because of dry. It's just a natural thing. It's January. These leaves should have fallen, come the end of November, but they just keep getting rain. And they all say, like, I know you love seeing all the birds and all the green, but that's still not what we expected this time of year. There's a change. And I just use that here in Orange County, if you were to say, what's changing? You might say, oh, I saw little blue herons. That's kind of unusual. And I could list a whole bunch of things which are different. But if you go to Galapagos, if you go to Costa Rica, if you go throughout the world, things are changing. Now, change is okay. Things have always changed. But this is a lot in a really short period of time. All right. So if we're asking how is wildlife going to keep up? Because there's new predators coming in, there's new parasites, there's new invasive species. The water levels are changing. The temperature is changing. If you're in the ocean, and I can find the right video in the list of 100. It's here somewhere. The oceans are warming and the pH is going down as it acidifies, which is affecting the corals. So there's just a gazillion things going on all over the place. And if you say, like, why are we losing the corals? What's the reason? Well, I mean, the ocean is warmer, the ocean is more acidic, the more hurricanes, there's just, it's not one reason, it's all of these things together. So living things can adapt over long periods of time. And here in a very short period of time, we are throwing an incredible amount of change at them. And there is, like, somewhere along, I've lost a playlist somewhere. There is long-term good news, but in the short term, this will continue while we are getting more and more heat trapping gases. Temperatures will continue to increase. And as you saw, not even COVID could stop us from increasing the amount of carbon. Like, I can't imagine what things would be bigger than COVID. And then likewise, another thing is just every year we put, between, this is 80 million because this was a couple of years ago. This year, the data just came out. It's somewhere between 71 and 75 million people on Earth who weren't here last year. But that's a lot of new people, all right, that are going to use fossil fuels, that need food, that need homes, that need, energy, et cetera. And so then these trends are not going to change. Now, global population growth is changing. A little before I was born, like around 1950, the average family on Earth had 5 children. It's now about 2.3, all right? That is far more sustainable and very close to replacement fertility. And so we think that by say the year 2100 something, like maybe 2130, maybe our population has leveled off and maybe starts decreasing. But it's likely to get to maybe 10 billion by then. So just, we're at 8. All right, if we get to 10, all right, that's 2 billion more people. That would be like 1 China and 3 United Stateses. So if you were to imagine in the year before the year 2100, which I probably won't see, but younger people, you might say your kids will, where on our planet are we going to put another China and 3 more United Stateses in the next couple of decades? All right. And you say, we can't do it. That's the wrong answer because they're coming. All right. And so, the changes which we're seeing now, all right, in the short term, in the next couple of decades, we're expecting this to accelerate. So, um, there are, there is some reason, to be optimistic. Birth rates are coming down. It'll take a little bit. There are ways, and I'm about to just kind of just talk about myself in just here's an example, but not kind of like, ooh, look at what I'm doing. So it's not that at all, but just individually we can do things. So I plug in my car every night. And my house, I made a phone call one day and I said, hey, instead of this electric provider, could I use this one that's now getting it from wind? So wind power is not only providing electricity for my house, but powering my car. So that's helping a little bit. I'm a vegetarian, all right? And just, plants have just a smaller carbon footprint than a lot of the animals that we tend to consume. So that's helping a little bit. If you use less stuff, all right, that will help a little bit. And then I'm sure all of you could come up with like, well, here are some things that I do. But then this is a huge problem. And so while individuals can make differences, we do need governments and businesses, to come in as well. So just that's actually one of the things to emphasize, where this can't just be like, what are you doing to lower your carbon footprint? Meanwhile, all the bigger aspects of society are continuing business as usual, because just it's too big a problem for you to fix or for me to fix. So this is something which is going to address all of us. Just last point, talking about like sea level rising in Antarctica melting, just I know that sounds like science fiction, all right? Just like, oh, that's like ridiculous. Now, if we could bring a dinosaur back from the past and teach it to talk, so already I'm being ridiculous, it would probably say a bunch of things. One of the things I think it might say is, one, pretty cold here. I mean, there's ice at the poles. The dinosaurs never saw that. The dinosaurs didn't have ice at the South Pole or ice at the North Pole. But they also then didn't have a southern Florida. Southern Florida was underwater. So if the planet were to be warmer than usual, or than we know it now, that's actually kind of normal for the past 500 million years. All right. If sea level were to be higher, like much higher, that, half of Florida is underwater, that's actually normal. So it's not saving the planet. The planet has lived with higher sea levels before, but we already have 8 billion people. We're going to 10 in the very near future. A lot of them live near the coast. All right. So it's not about saving the planet. It's about saving, like life as we know it, and then the suffering and the lifestyle of all of, those who are now going to have to, where do I find food, now that the cropland is too dry, or et cetera. So we're all in this together, all right? Because even if it's hurricanes affecting you over here, or drought that's affecting you over here, it's affecting everyone. It's certainly affecting the wildlife, which we care about. So, keep watching. And even if you're going out and participating in bird counts, like what is this going to do to the birds? We have no idea. So I know people did it here at the Bashville, we in Orange County Audubon. Just every year we go out over the Christmas holidays and we count birds and we measure all the data so that we're monitoring, what is going on. The Bashkill is an advocate for this great wetland which we have here. So if you get a chance to go out and enjoy nature, if you get a chance to join an environmental organization, you might find hey, I'm with people, I like going bird watching, and I met some people who like to go bird watching. We now go bird watching together. That's a great thing. I'm sure they would love your company. On that, there is the Bashkill Area Association and MEEK, this environmental center, does a lot of programming throughout the year, whether it be Eagle Watches, where you can go to the boat launch here on weekends in the spring and look at the bald eagle nests through a spotting scope with volunteers pointing stuff out, or presentations. I know right now there's a winter plant hike going on. I have calendars, so if you wanted to give a donation to the Bashkill Area Association, feel free to take a calendar with pictures of this area, but also with a schedule of events for the upcoming year. I'm going to ask if there are any questions, but if people start to break up, I just want to say thank you. This is important, and it doesn't get better unless people care. And the fact that you're here, you're among the people who care. So among like how we fix this, situation, you're part of the answer. So, I'm very grateful, for your interest in that. So I'd like to thank you for coming. If anyone has any questions, feel free to shout out. Otherwise, have a wonderful day. Yes.
Any speculation about the carrying capacity of the world and 10 billion?
All right. So I hate to answer this question. I'll tell you why. How many people can Earth hold? That is, so if I were to ask that question, I'm not saying you, no, this is not a criticism. So if I were to ask that question, it would be right for you to say, like, what a horribly biased thing that you just said. Because the last UN estimate I read was that every single day, 40,000 people die of either hunger or a hunger-related disease. You could argue from that standpoint, we have already passed the capacity of what we can, the number of people we can adequately feed, and saying, oh, we have more to go, in some way disrespects us. Another one, because I was in the Peace Corps for 2 years in the 90s and I lived in Paraguay. When we ask how many people can Earth hold, who are we talking about? Are we talking about all my nieces and nephews in Paraguay? Or are we talking about the people in this room, including myself? Once again, I'm including myself in this. Somewhere here, I don't know if I can find it. Once again, the more videos I make, the harder it is to find the one that I want at the right moment. Somewhere here, I have a video which essentially, if it asks, like, how many people can Earth hold? Well, like, what people are we talking about? Are we talking about, like, me? Because we would need like 3 planet Earths to hold 8 billion me. The only reason we fit 8 billion people on the planet is because most people don't have a car. All right, most people don't use the amount of fuel that I do, all right, or generate the amount of waste that I do. And by that, I mean the average American. So that's a tough question to ask, because if you were to, there are people living on Earth who have very few resources compared, like, so Earth could fit a whole lot more of them, all right, than it could have. So it's a hard question, not just the number of people, but how many resources they use.
So what about the influence of these wars and pandemics? Is that slowing down the increase that was expected?
So that would be complicated. I'm sure we'd have to deep dive. So I would answer this way in a generalization. Destabilization is bad. All right. So like if you were, so for example, the conflict between Ukraine and Russia, there have been buildings bombed, there has been fuel used for that otherwise wouldn't have been used. This was bad for the planet. Like, war does not make the planet better, and just so more energy use and the like. When we look at global population, as far as I know, no country has decreased its birth rate before first decreasing infant mortality. All right. One of the reasons you have a lot of kids is because if you have 6, 2 or 3 are going to die, all right, then you have a few more that just kind of built into the culture. So as infant mortality goes down, then so does fertility. As we increase war, famine, all of these things, then just this will tend to increase fertility. So we want a stable world. All right. So, war and famine, like none of these are overall making the long-term situation better. Like stable people say like, oh, here's this sustainable society. Let's just kind of keep this going. That would be my answer. But then each conflict, each problem, I'm sure would have individual nuances. Anybody else have questions? Yeah.
Talked about earlier with the temperature increase and how quickly it's gone up, whether it's in the ocean or the climate. So when you think of the future, okay, I mean, my brain is like on fire. Like, is this going to happen in 10 years or 20 years? Am I not going to see any more of my little animal friends? I mean,
So no, it is.
I guess my question is really like, how much further is it going to go before everybody sees like, wow, this is really impacting me?
And this is why I kind of opened up. By all means, please don't listen to me like my students in my class. Like I tell them that, don't listen to me. But we have the world's experts measuring this every single day. All right. And they have free websites, just so like you can go NOAA now and ask like, what's the size of this, what's of that. So nobody knows. All right. But as far as like what we predict, there are, the predictions we can make from that. The thing that I fear, so here's just a silly little analogy that I have, but if you think of the Titanic, it was big and it was going too fast and it saw an iceberg. All right. And when it saw the iceberg, it said, we better move. But if you have this big thing that's just moving too fast, you can't turn on a dime. And they just couldn't, and they hit it. A planet is big. And getting back to your question, if you see that increase, that's not just increasing the temperature in your house. All right. That's increasing the temperature on a planet. Planets are huge. And if you were at some point to say, all right, this is too hot, it's like stealing the Titanic. You can't just turn a planet's climate on a dime. Now, who knows what future technologies there might be. So if we were to all plant more trees or develop technologies which would suck carbon out of the air. Now, like, so when we run our cars, we're putting carbon into the air. Could we develop machines which are sucking carbon out of the air? So there are plenty of things that if we really wanted to, if it became a priority, we could maybe figure out ways that would start this. But your point is, that's a trend going up. And the best case scenario is it goes up at this speed or slows slightly. But if it starts to speed up, as I said earlier, I don't know what we do. All right. And once again, some of us will be fine, like getting back, like, you know, with just as horrible as this sounds. I mean, there have always been catastrophes. There are catastrophes now. You know, they don't wipe out everyone. So I'm not saying this is the end of the world, you know, et cetera. But we obviously don't want that. We don't want, you know, our children and grandchildren grow up in a world where there's more suffering and there's, you know, more disaster, et cetera. We want less. So I don't know where that goes, which is why we stay tuned and we watch, you know, the experts and watch the trends. And so sorry. Yeah,
That's the answer, but just based on the trends and how things are going so quickly, you know, are they already predicting what's gonna happen 20 years from now, 50 years from now? I mean, I'll be gone 50 years from now, so, but I still wanna do something now for the next generation.
sure.
Yeah, like the Titanic analogy, like not to be negative, but like we're just gonna die.
No, so
But like if it's like a big issue and everything, like it's like not like to be realistic, no one's really gonna stop it. So like, do we have like 20 years or like?
So I think when it starts to get so my predictions, if you're asking for predictions, my predictions is when it starts right now, we're like, oh, it's just, you know, and I'm, you know, I'm going to say a couple of things. I hope I don't offend. It is possible if you see wildfires in LA to instead say like, wow, you know, it's a hot, dry climate. It's, you know, like, let's focus on, you know, like maybe some local event in LA that maybe, you know, was, you know, involved, which it might be, but it's also part of a global trend. So it may be some people are ignoring the global trend to focus on this thing. If you were saying, you know, like, oh, you know, there's a serious hurricane that hit the Carolinas, instead of saying, well, the ocean, you know, the Caribbean's warmer, all right, and you expect in warmer water more hurricanes and them to be stronger, or say like, oh, like I think the government is using lasers to direct, or like, so for now, some people can do that. We may get to the point where you just can't anymore. It's just too much. And we are really resourceful. And if you think of just, you know, what we've accomplished technologically in the past, you know, century, I think we can figure things out if we put our minds to it. I think just a lot of people just haven't made this a priority yet. And as far as your comment, like we all die, I don't think so. Like, I think it's going to be harder and harder to live in Miami and New York City. All right, Miami first. Miami is already having to redistrict, you know, some of its things, and it's big hotels right on the thing. They're starting to sink, you know, and salt water's getting into the aquifer. So, not talking about dying, but you know, like if you're going to live in Miami, that's harder. Or if you're growing crops in the West, if it just gets drier and drier every year, you got to, you know, you're not dying per se, but like the life that you knew now has to change because there's not the water. Or if, you know, Lake Mead drops anymore, Las Vegas has an issue. Like, where are you going to get your water from? You know, golf courses, I don't think you can do the whole, I'm watering my lawn the way I used to, you know, et cetera. So I think before, you know, it's this apocalyptic, you know, Last of Us, you know, type of, you know, show, I think it's just, you know, life as we knew it is changing. Like, so maybe not for you in your home, but if you're on the coast in Miami, or if you're on a farm, you know, and then, so then a lot of that. That would be my answer.
Okay.
Anybody else? Once again, thank you so much for coming. The only way this gets better is if people care, and thank you for caring. All right, and we're gonna, do more talks. There'll be a lecture series Monday nights at Orange County Community College, but also they'll be online if anyone want to join. There's gonna be frequent bird hikes. If anyone wanted to give a donation to the basketball, feel free to take a calendar and have a wonderful day.
Okay.
Okay. Did anybody have questions online? Oh, I do see something in the chat. I'm sorry, I wasn't checking. Okay. You're welcome, John. Okay, thank you.